so I have posted the homework template. Here, let me rename this. This is the 1025 RMD template. Okay. What happened? Okay, so this is, I've posted the templates for Homework 5. Homework 5 is a Monopoly simulation, okay? It's, I'll explain. So, when I first did this, I came in with the assumption that everybody has played Monopoly, but I was informed that not everybody has played Monopoly. So, Monopoly is this grand old American traditional board game, and an interesting story. The goal of the game is to go around, purchase properties, charge rent on the other players, and the goal is to try to bankrupt the other players, and you be the sole person who controls all of the property on the board. And interestingly enough, it was originally called the Landlord's Game, and it was designed, the creator of the game originally had the intent of showing kind of the ruthless business practices of landlords and to kind of make some social commentary on the evils of capitalism. But it turns out that when people played the game, they enjoyed being the ruthless business person, and they enjoyed putting people other players out of business and bankrupting them and being this greedy landlord tycoon, and it became a runaway success. And so now everybody has not everybody, but many people have either good or bad memories of playing Monopoly with their family and possibly getting in a fight over hotels and houses and whatnot. But anyway, this is how the board is set up. There's 40 spaces, and as far as the game goes, I've labeled Go number 1, and it goes 2, 3, 4, 5, 6, 7, 8, 9. This is 11, and there's 10 spaces on each side for a total of 40 spaces, and each turn you roll 2 dice, so you can go anywhere from 2 to 12, and you move that many spaces down the board. And wherever you land, you have the option of purchasing the property if it's available, or if it's not, if somebody else owns it, you have to pay rent. And you just take turns buying things, trading things, paying each other rent until you run out of money or other people run out of money. As far as our simulation goes, all we are going to do is simulate the player movement. We're not going to simulate money. We're not going to simulate owning or selling properties or anything like that. We're just going to simulate where the players move. And the question we have is, are certain spaces more likely to be landed upon than others? And the answer is yes. Okay, because of certain rules in the game, some spaces will be landed on more frequently, other spaces will be landed upon less frequently. Okay, so if there were no rules, then we would just keep rolling and moving around and around and around, and all 40 spaces would be landed upon fairly equally. So if we do 100% divided by 40, then each space would be landed upon approximately 2.5% of the time. After we've implemented the rules, we're going to find some spaces are landed more than 2.5% of the time, other spaces are landed on less often than that, okay? So, one of the rules is if you ever land on this spot, if your token ends up here, you immediately get sent to the jail space, okay? So when you finish the game, or when you finish your simulation, what we're going to be doing is we're going to be keeping track of how often somebody has landed on a space. And we're going to run like thousands of games. And when we finish the game, this should have a total tally of 0, because the rule says nobody can end their turn on this space, because if you land on this space, you get sent to jail. Okay, and so this is kind of an assignment that illustrates the idea of computational statistics and using simulation as a way to answer questions of probability that might be a little bit too complex to answer in an analytic fashion. You could look at all of the rules of Monopoly and come up with some analytic equations to calculate the probability of every single space. It is possible. You'd create a giant 40 by 40 transition matrix and take that to its limit. It is possible, but that's not what we're going to do. We're going to instead just run, maybe 1,000 simulations of a bunch of different games and see which spots get landed upon more frequently than others. All right, so I've created this RMD template. You know what? Let me change the file properties so they download rather than display them. So appearance, force download, and then this settings here. Okay, so this should fix it. So these files download now. Okay. Okay, so we click this, it downloads. We'll open it up in actually, I got it right here. Okay, and so the first, as you go through this, it just kind of goes through a bunch of the different rules for movement, okay, and it talks about all of these things. So yeah, if you land on the go to jail space, you're going to move to the. You will never end your turn on go to jail. You will end your turn in jail. If you roll doubles, two of the same number, so like 2 2s or 2 6s or whatever it might be, you get to roll again and have another turn. If you roll doubles 3 times in a row, then you are sent directly to jail. Okay, there's a rule in Monopoly. Okay, the official game rules are available in this little PDF thing, and you can look at that. There's also a few spaces on the board that say chance or community chest. Okay, so you can land on a space that has this blue box or this question mark. Those are the chance and community chest spaces, and if you land there, you draw a card from these decks, and the cards will have instructions, things like move to this other space, go to St. Charles Place, or go to Boardwalk, or go to Go, or something like that. Other cards will say like collect money. It'll say like bank error in your favor, or you won second place at a beauty contest or something. And so you'll follow those instructions, and as far as our simulation goes, only the ones that move you spaces are of importance to us, because we're not keeping track of money, so the other cards have no impact on our simulation. Okay? It might say something like move to the nearest railroad or move to the nearest utility. The utilities are the electric company and the waterworks, so the electric and water companies, those are the utilities, and then the railroads are the ones with trains on them. You always move forward. So if you are on this chance space and it says move to the nearest railroad is going to be Pennsylvania Railroad. It's not Reading Railroad, okay? Because you always move forward. So you can do that. if you land on space 11, just like if you start on go and you roll 10, you would land on this space. You are just visiting jail, okay? Which means on the next turn, if you roll a 3, you would just move 1, 2, 3, and you would end up on States Avenue, okay? However, if you do something such as land on the go to jail space, or you roll doubles 3 times in a row, or you draw a card that sends you to jail, then you are sent to jail and you are, quote, in jail, okay? Which means on the next turn, you don't really get to move. You have to kind of jump through hoops in order to move, okay? One option is to pay money to get out. We are not going to simulate that. We're going to just say you don't have that option to pay money to get out early, okay? But you do get out if you roll doubles. If you roll doubles, you get out of jail and you move, okay? So, if you roll a 2, you would move to the electric company. And when you roll doubles to get out of jail, you don't actually go again. You roll doubles, you get out of jail, and your turn ends. But if you are in jail on your 3rd turn in jail, so let's say you're in jail, you roll, you don't get doubles, so you remain in jail. The next turn you start off in jail, you roll again, you don't get doubles, you stay in jail. Your 3rd turn in jail, you roll, whether you get doubles or not, you're going to get out of jail, okay? And that's going to be that. Okay, so that's kind of described in here as far as the jail rules go, and so you can read up on this. All right, and then as far as what you are going to do is we are going to run a simulation, 1,000 simulations of a 2-player game that lasts 150 turns. Okay, so in a real game, the real game goes until somebody runs out of money. We are not keeping track of money. So we are going to do an approximation, and we're going to just say we're going to pretend that games last 150 turns. Some last longer, some last shorter. I don't really know, okay? So you're going to do 1,000 games. Each game's 150 turn. Each turn is going to have, there's 2 players, and it goes back and forth. So you got player 1 and player 2, and every time you're rolling 2 dice, and then sometimes if you roll doubles, you get to go again, and that still counts as 1 turn, and so there's going to be a lot of dice rolls, okay? And your job is to keep track of where everybody lands. Okay, so you're going to have a vector of kind of 40 values, and that's going to be, how many times do people land on go? How many times do people land on Mediterranean Avenue and Baltic Avenue and things like that? Okay, and so that's what we will do. For your convenience, I've created some data frames for you. This is the game board. Okay, this is all 40 spaces, and here is a data frame for the chance deck, and here's the data frame for the community chest deck. So if we look at game board, these are the 40 spaces, starting at space 1, which will be go, then Mediterranean Avenue, so on and so forth, and it ends at space 40, which is boardwalk. Okay, but it loops around. So once you go past boardwalk, you're back at go. Okay, and then we have the chance deck. All right, and I've arranged these so that the first ones are the ones that move you places. So we have advance to go, advance to Illinois Avenue, all of these things. Go back 3 spaces. Okay, and then these last 6 cards, they don't move you anywhere. Okay, so these are like, they give you money, get out of jail free. That's a money related card, so it doesn't factor into anything. Okay, it's just whether you or not you have to pay the fine to get out of jail. And so these things you don't really have to simulate, but they are part of the deck. Okay, we also have the community chest deck, which I called community deck, and only the first 2 cards in the community deck move the token. One is advance to go, and the other one's go to jail. So those are the only 2 that move the token in the community chest deck. Okay, and so as you go, you're gonna code these, right? If the card drawn is 1 in the chance deck, which is advance to go, you're gonna move the player to space 1, which is move to go, things like that. All right, so as I wrote, at first blush, this task may seem overwhelming, but yes, question.
I was going to ask for choosing cards. Are we assuming that we're choosing with replacement until we run out of cards and then you refill the deck, or are we assuming we're choosing like with
yeah, for simplicity, we can choose with replacement. Okay, we can just randomly sample 1 through 15 or 1 through 16. But if you wanted to build a reference class that says we're going to keep track of which cards we've drawn and which ones we haven't, you can do that. But yeah, that's normally how you play, right? You normally cycle through the thing. Yes.
So if like someone like gets into jail and they have like a chance card that's like a get out of free jail, will that also be factored in?
That's not factored in.
That's not factored in.
That's not factored in. Yeah. So the go to jail, get out of jail free card, it has no bearing on the game. Okay, because if you get into the world of competitive Monopoly, they have different strategies on how you should stay in jail or not stay in jail. And the general consensus is that early on in the game, while there's properties still available for purchase, you want to get out of jail as quickly as possible so you can buy more properties. But later on in the game, after all the properties have been bought, you want to stay in jail because that reduces your chance of landing on an opponent's piece and paying out money. And so, but what we're going to do is we're going to just implement the long stay strategy, which is stay in jail until the rules of the game kick you out. So the rules of the game will kick you out if you roll doubles, or the rules of the game will kick you out if you stay 3 turns in jail. Okay, on your 3rd turn in jail, you are kicked out of jail no matter what. Okay, doesn't work that way in real life, but that's how it goes. Okay. So, you might look at this and you're not sure where to start. So we're going to try to break it down into smaller, more manageable pieces, okay? And I have actually started this for you. The first time I assigned this, I didn't give this, and then students were just completely lost. So we're going to start with a simulation that moves pieces around the board and keeps track of where they land, and I'll explain how this works and how I've implemented this with some reference classes. Then you can add complexity to that one part at a time. And so these are the parts that you are responsible for. So the easiest one is implementing the rule for if you land on the go to jail space, you're going to be sent to jail. That one's pretty easy to implement. Okay. After that, you're going to implement the drawing of the cards from the decks. Then you would implement rules for rolling doubles and going again. And if you roll doubles 3 times, you get sent to jail. And then lastly, once you're in jail, there's rules that you have to keep track of how many turns you're in jail. And on your 3rd turn, you get sent out of jail and things like that. Okay. Okay, so here's just some, more instructions and things like that. Okay, let's look at some of the stuff that I've written. Okay, we'll do download Monopoly Getting Started example. This is just some R code here. Okay, so I've implemented, I have a dice function. The dice function here, if you call it, basically it will return a list. One is the faces of the dice you rolled. Here we rolled a 4-2. Is that doubles? It's not. And the movement of this will be you move six places. Okay. If we do dice, here we rolled 3-5, also not doubles, and you move 6 or move 8, and here so on and so forth. So this is the dice function. Okay, and this just uses the sample feature, and it samples 1 through 6 twice with a replacement. I'm also creating a reference class for dice, okay? And this allows you to have manual dice, okay? And here I've implemented this using basically 2 fields of importance and one being verbose. So 3 fields. One is the rolls that we're going to do and then the position. And what this allows us to do is it allows us to manually control the dice. So as you work on your code, you might want to test this out. You might want to be like, okay, I've written the instructions for if I land on a chance space, it's going to draw from the chance deck. Now, if you were using the random dice, you would roll the dice and you'd say, darn it, I rolled the wrong space and I didn't land on chance. So the manual dice allows you to say, I'm going to force you to roll 7 so you land on the chance space or something like that, okay? Or if you wanted, part of the rules is if you roll doubles 3 times in a row, you get sent to jail, okay? Maybe you've coded something like that in your program, and you want to test this out. If you were using the random dice, you'd have to organically wait for the dice to roll doubles 3 times in a row, which might be a long time, right? The probability that's like 1 in 216, so it's a lot of dice rolls that you have to endure. With the manual dice, you can forcefully say, you're going to roll 3-3, 3-3, 3-3, and now you get sent to jail, something like that, okay? So we can do that. So, for the test of purpose of testing, the manual dice is a great thing to have. Of course, when you run the simulation, you'll do the random dice, okay? And so the manual dice, there's only one method, which is just roll, and it does this. The way the manual dice work is you give it a vector of the faces that will turn up. Okay, and so think of this list as a piece of paper that says, like, here we're going to roll, it says 6, 4, 5, 3, 3, 5, so on and so forth. And what you're going to do is you start off and you just say, we're going to start at the position 1 and we're going to return kind of the next 2 values, position 1 and position 2. And then you're going to pass this on, or actually I have it as position 0 and then return 1 and 2. And then you update the position. Now it's going to be updated to 2. And so basically you're just passing this list on to someone else. And rather than having to rewrite the entire list of vectors, you're just going to say, start at the second number or the 4th number or so on. And so the only thing that really gets updated when you roll the dice is the position, and the rolls themselves just remain. Does that kind of make sense as far as how the manual dice work? So it's a vector of dice rolls. So it's basically just pretend there's a piece of paper of all of these dice rolls that we're going to do, and rather than updating the piece of paper every time we roll, we're going to just have a number that says start at this position on the list. So the first time you're going to start at the very top, and then the next time you're going to start 2 spots down, and after that you're going to start 4 spots down and 6 spots down. And that way you don't have to rework the entire vector of rolls. Okay, and it's implemented that you can read through the code on the reference class for dice, but basically it's going to return back from the rolls vector the next 2 positions, and it just updates the position by incrementing them by 2. Okay, and then it asks, are they doubles or things like that. And then now I'm going to implement a player reference class and a tracking reference class. So player reference class is for our players, so we can keep track of where they are on the board. And then we will have a tracking reference class to see which spaces we have landed on. So this has been implemented with reference classes, so you might have to go back on your notes for object-oriented programming on reference classes. I think this is the way to do it. And so for this basic implementation that I've set up, I just have really just one field. I've got 2 fields. One is the position of the player, and here I have verbose, which is whether it will return a bunch of extra text output as far as like diagnostic information goes. So verbose is either going to be true or false. If it's false, it's just going to run and not print things out to the screen. If it's true, it will constantly be printing out information on the screen so I can kind of understand what it's doing. And here, the only thing I'm keeping track so far is the position that the player is on the board. As you implement the rules for the game, you're going to need to add additional fields, okay? fields like, is the player in jail? What turn is the player in jail? Did the player roll doubles? Which turn has the player? How many times has the player rolled doubles? Things like that, okay? Maybe you didn't catch that. Maybe you'll need to rewatch this part of the video to see, you know, what other fields you might want to add for the player reference class, okay? And here I've added a couple methods for the player, and you'll probably want to add a few additional methods yourself. One is move the player n spaces, and the other one is have the player go to space n. So those are the two methods that I've created for the player reference class. So you can see for move n, really the only code is position plus n, update the position there. Okay, position becomes position plus n. And then if the position is greater than 40, right, the last spot on the board is boardwalk, and that's space 40. And if we've gotten past that, then we have to say, okay, you've wrapped around the board, and so position becomes position minus 40. So if I'm at boardwalk, position is at 40, and I go plus 5, then this becomes 45, and then I say, okay, well, let's do 45 minus 40. I'm now at position 5, which will be, I don't know, tax or the railroad, something. Okay. So that's that. All of this other stuff that says if verbose is just, so when we create the player, we can say verbose is true or verbose is false. So if it is verbose, you know, cat some stuff onto the screen so we can kind of see what it's doing. Otherwise, just move the player and don't tell me what you're doing, okay? So while you are trying this out, it's very useful to have verbose true, but obviously when you do your 1,000 games of 150 turns, please, it's actually a requirement, do not have verbose turned on, because it's gonna return out, you know, 300,000 lines of verbose output, which is just too much, okay? And so once I've created my reference class like this, the other method is go to space n. So this will be like if you draw the card that says go to boardwalk, you're going to say go, you know, you're going to use go to space n space 40 being boardwalk, and then you would update the position to space 40. Okay, so we created the player reference class, and here I'm going to create two players. Player 1 is a new instance of the player reference class, and player 2 is a new instance of the player reference class. Both of them have verbose equal to true turned on so I can kind of see what it's doing. Over here, I'm going to create a tracking reference class. Tracking reference class is going to be, you can just see there's only one field, which is the tally. It's going to be a vector of 40 values that keeps track of how many times each spot has been landed on. So go will be the first value in the vector, boardwalk will be the last value in the vector, and you know, if go gets landed upon, we just increment the tally right there. And you can see there's only one method, which is increase count, which will take the tally at position n and add 1 to it and update the tally there. Okay, so that's going to be our tracking reference class. And I will create a new instance of this called space tracking, and the new instance is just going to have, it's going to repeat 0 40 times. There's our tracking reference class. Okay, and here, let me do, here's my dice, and I'm going to do the verbose dice for a second here. So we'll do take turn. So take turn, here is my function for take turn, which is roll the dice, move the player, what the dice roll movement is, and then after you move the player, increase the count at the location of the player's position. Okay, so take turn is a function of the player reference class and the tracking reference class, and what we're doing is we're going to roll the dice. That's going to be roll. We move the player. We're calling the move n method. How many do we move the player? We move it roll $movement, the movement number of the roll. Okay, once we've done that, so this, because it's reference class, I don't need to say player position is, you know, store into player position, you know, current player position plus movement. We're using the reference class methods, which update the things themselves. And then after we do that, we're going to say increase the count in our tracking reference class, and which position are we increasing? The player position. So this will be our take turn function. Okay, so let's just try this out. Here I'll do set seed 1, and I've got take turn player 1 space tracking. So this takes the player 1 reference class and the space tracking reference class, and this is what it does. It says we've rolled a 2, 3. This is the output of the dice, and this is what we have. Because I've got verbose turned on, it tells me player starts at position 1, which is go. Player moves 5. Player now at position 6, which will be reading railroad or something like that. Okay. We do the same thing for player 2. Player starts at position 1. We've rolled 10, and so now we're at position 11. Okay. And then we can look at the tally vector in space tracking, and we see indeed we have incremented the tally here by 1 in position 6, and the tally at position 11 by 1. Okay. And we can see, you know, where is player 1, and we can see player 1 is in position 6, and verbose is set to true. Okay, so let me, when you do the simulation, let me turn off, as far as the dice goes, we'll go back and let me just set the dice roll to, what did I do? Okay, for the take turn, I'm going to turn off verbose equals true, so it's no longer verbose dice. Okay, so when we run the simulation, I'm going to do set seed 1. Okay, I'm going to create a new blank space tracking reference class, and then I'm going to run 100 simulations, and each time will be a new game. A new game, I'm creating a new player, and then I have 150 turns. So I've got 1 through 150, and here we've got verbose turn to false, okay? And so this will run 150 turns, and we've got basically it's going to do take turn player 1, and then take turn player 2. So it just does this back and forth, take turn player 1, take turn player 2. It does that 150 times, and that will be one game. When that finishes, then it will go to new game 2, creates 2 new players, does 150 turns alternating. When that's done, it goes to new game 3, creates 2 new players, and has those alternate. Okay, so when I do this, it runs new game 1 through until it gets to 150, or 100, okay? And now we are done. That ran 100 games of 150 turns. And we can see, we can do space tracking tally. We can just kind of look at this. Okay, and that's the count that we have. And I'll just bind this to the game board, and then I will also bind kind of the relative frequency. Okay, so let's take a look at this. And when we look at this, because we haven't implemented any rules, all we've done is have the players move around and around and around 150 times, we see overall these spaces have been landed about 750 times each. Some a little bit more, some a little bit less, and that's just a result of random chance. And so everybody's relative frequency is right around 2.5%, right? 100 divided by 40 spaces, 2.5%. So that's what we have. But yeah, just by random chance, you know, this one's a little under 2.4, and this one's at 2.7%, but right around 2.5%. That's what we have. Okay. Let me just kind of show you what would happen, and then if we want to see how many times this is 30,000 space trackings. Let me just do we'll do 4 games of 5 turns. And here I will do verbose equal to true, and you can kind of see what would happen. Verbose is true, and then let me go back, and as far as take turn goes, we'll have the verbose dice, just so you can see kind of what would happen. So here we'll have verbose dice there, and then each game will set new players but verbose players, okay? And so you can see the output here, it just produces a lot of output onto the screen. And this is 4 games of 5 turns each. So it goes player 1, rolled a 2, 3, we move 5 and we're at 6. Player 2 rolled a 4, 6. So it goes player 1, player 2, so that's 2 turns. Player 1, player 2, that's 3 turns. Player 1, player 2, that's 4 turns. And then player 1, player 2, that's 5 turns. Okay, that's the end of game 1. New game 2 has a total of 5 turns between player 1 and player 2. Then it becomes new game 3. Player 1 and player 2 each take 5 turns. And new game 4, player 1 and 2 each take 5 turns. Okay, so obviously you do not want to do this verbose output for 150 turns of 1,000 games. Okay, that will overrun your screen buffer and just be, you know, way too much output. Okay, so we have that. Also, let me just show you how the manual dice work. Okay, so here I'm going to do this, and we will set manual dice. So here's the vector of kind of some dice turns. Okay, and here you have to set the dice to be no longer the old dice function, but we're going to use the roll method implemented in the set dice reference class. Okay, we'll create a new space tracking, just a blank player 1 reference class, and then here we'll have the player do 20 turns. Okay, oops, let me go back to, I'm sorry, under take turn I've got to use this and not this. Okay, so let me just redo this. So this is using the manual dice that we've created, okay? And so you can kind of see this is being the verbose output. You can see it uses the dice rolls here. Use a 6-4 and then it moves the player accordingly. Then 5-3 and it moves the player accordingly. Then 3-5 and it moves the player accordingly there, okay? And just so kind of you can check if your output is working correctly, I have very verbose output in posted on the board. So, you know, turn 1, you roll the 6-4, player's at 1, go, player moves 10, player's now at spot 11, which is jail, and we are going to increment the tally at spot 11 for jail, okay? And then we do turn 2, we roll 8, we're starting off at jail, player moves 8, player's now at 19, Tennessee Avenue, and then we're going to increment our space tracking thing. We're going to put a tally at space 19, Tennessee Avenue, okay? And this, you know, here I've forced it to run doubles several times. So here it will go 4-4, and here it tells you that the double count is now 1, and we move, we put a tally here, but because we rolled doubles, we take another turn. We rolled doubles again, doubles count is now 2, we move, we increment the tally, we roll double, we take another turn, we rolled 2-2, the double count is now 3, which means we're going to jail, okay? And so obviously if you had used the random dice, you would have to probably wait a long time for this, but because of the manual dice, we can force it to roll doubles 3 times in a row. And here, now that we are in jail, we rolled a 4-3, which is not doubles, so we're staying in jail, and we increment the tally at jail. Here, we rolled 4-4, which means we rolled doubles, we get out of jail, we move 8, we're at Tennessee Avenue, we put a tally at Tennessee Avenue, so on and so forth. Okay, so you can kind of see, I believe I've followed all of the rules in the code that I've implemented, and then this is just kind of the tallies at the end of my 20 turns here to see what has happened. Okay, are there any questions? Yes, Daniel.
So we go to the jail spot itself, should that always be 0?
Should always be 0, yes. You will never, according to the rules of Monopoly, you can never end your turn on the go to jail spot. Therefore, the tally count at the very end of the game, after all of your simulations, go to jail spot will be 0, okay? And that's actually gonna be one of my grading criteria. I'll have the grader check to make sure go to jail count is 0. Okay, other questions? Yeah, there's lots of rules. I recommend kind of the implementing by starting with the simplest things to implement, and the most complicated thing to implement will be the jail, keeping track of how many turns you're in jail, right? So, you know, as you're thinking of your player reference class, just it helps to kind of work on paper and just say like, okay, when I'm playing the game, what are the things I need to keep track of, right? So normally you'd have to keep track of your money and your properties, but you don't have to worry about that. But when you're playing the game, you do need to keep track of like, how many times have I rolled doubles, right? Because on your third doubles, you get sent to jail, right? So you do need to keep track of that. So if you need to keep track of that, that probably needs to be a field in your reference class, okay? You also need to keep track of how many turns you've been in jail, right? Because on your third turn in jail, you're gonna get out no matter what. So that should be a field to keep track of, okay? Are there any other fields you need to keep track of? You know, you'll have to think about that and do that. And then if there's something, you know, probably create methods for going to jail, right? What happens when you go to jail? Then obviously you're going to get sent to jail, so the position gets updated to the jail spot, and then you probably reset your jail count, turn count to 1 or something, you know, things like that. So think of what you need to keep track of, and you know how each of these rules affect that. Okay. Are there any other questions? No? Okay, then we'll end here, and I'll see you guys Wednesday, maybe. If I don't see you Wednesday, have a great Thanksgiving holiday weekend, and we'll see you when we see you.